All right, our notes today focus on dividing polynomials by a binomial. So we have dividing polynomials by a binomial. So we should be thinking, what does this mean? Well, by polynomials, these are going to be things with multiple terms. Binomials will have two terms. So an example would look like that we might have x squared plus 7x minus 8 over x minus 1. And here are the steps we're going to follow to do this. So first step, step 1, is we're going to factor the numerator. Or the top of the fraction. Okay? So we're going to factor the top of this fraction. So x squared plus 7x minus 8. So I can factor that in my calculator. My calculator might look slightly different than yours, but we should still get the same answer. I go to Apps, Polysmelt, Root Finder. It should have an order of 2. Auto or fraction. Everything else looks good. All right, we're going to put coefficients of 1, 7, so plus 7, positive 7, and negative 8. So that's going to be minus 8. Again, I know your screen looks slightly different because we have different versions of the calculator, but we're going to get the same answers. Okay, so we get that our solutions are 1 and negative 8. That means that our factors are really going to be x minus 1, x plus 8.
Hannah Hendricks, please report to the front desk. Hannah Hendricks, please report to the front desk.
So we've done our first step. We've completely factored the numerator, or the top, and this is what it's become. Okay. Notice the bottom didn't change at all. So what do we do from here? Well, for step 2, notice there's going to be something that's common in the numerator and the denominator. So we're going to cancel out the common factors. So cancel common factors. Because we're dividing, and anything divided by itself is just 1. So 1 times x plus 8, we'll just keep it x plus 8. So we can literally just scratch through them. So those are gone. So last step, the remaining factor is our answer. So all that remains, we crossed out x minus 1, all that remains is x plus 8, so our answer is just x plus 8. And that's it. So hopefully by doing this, we're not going to have an answer in a fraction anymore. By canceling out that common factor, we're just going to have a single, hopefully just a binomial, possibly a polynomial, but probably just a binomial in our final answers. So let's see some other examples of this. So let's start with number 1. All right, so we're starting with x squared minus 10x plus 21 over x minus 7. Okay, so remember step 1 is to factor. So I'm going to factor the top. I'm only factoring the top part. This bottom part, in fact, in the next x minus 7, that's going to stay the same. Okay, so if you want, you can use your app. So I can just coefficient, I can clear these. And I've got a coefficient of 1, followed by a negative 10, plus 21. I'm going to double check and make sure that I have everything typed in correctly, because usually when we get an error, it's not because we don't know how to use the app, it's because we're just entering something wrong. Okay, we get our solutions are 3 and 7, so we write those as factors with opposite signs. X minus 3, x minus 7. Okay, our step 2 was to cancel common factors. So now we're going to cancel. So we've got this nice x minus 7 in the top and the bottom. So those are gone. So whatever's left is our answer. X minus 3. X minus 3. And that's it. Let's try some more. So for number 2, we've got m squared minus 4m minus 45. All of that over m minus 9. going to factor the top only. The denominator is going to stay the same because we're hopefully going to find something that we can factor out. So I'm going to clear. I've got coefficients of 1, -4, and -45. Okay, 1, -4, -45. Okay, we get solutions of -5 and 9, so it's fine. So we're going to have x plus 5 and x minus 9. Awesome. Next step is to cancel the common factor. So cancel. What can we cancel? X minus 9 on the top, m minus 9 on the bottom, and I should have really written these as m's. So that's something that we often do is we're so used to using x, but I really do need to keep the same factor. So I'm going to change those to m's. So those match up. Only thing that remains is m plus 5. That's our answer, m plus 5. All right, what if something looks a little different? So we said we're dividing a polynomial by a binomial. Remember, a polynomial can have 3 terms, it can have 2 terms, it's just anything more than 1. So what if we had something like this with 2 terms? So let's say we have y squared minus 25 over y plus 5. So this looks a little different because we're used to seeing trinomials over binomials. This is actually a binomial over a binomial, but that's okay. We're going to follow the same steps. We're still going to factor the top. Okay, we're going to leave the bottom alone, so the bottom's still going to be y plus 5. And you can certainly use your app to factor this. So if I want to do that, I'm going to clear. I've got a coefficient of 1 with the variable squared. I don't have anything with x, so I'm going to leave that as 0. And then I've got minus 25, so I need to make sure that mine says minus 25, or in your calculator, you're going to put in negative 25. All right, let's solve. So we have solutions of 5 and negative 5. We're going to switch those and say y minus 5, y plus 5. And we see that we nicely have a top and a bottom factor that match up, cancel out, and our solution is whatever's left over, y minus 5. Okay. One thing to notice, so you can certainly use this factoring app. I want you guys to be able to use the apps on your calculator, but we should notice when special cases like this appear. So automatically we notice that y squared minus 25 was different than the other ones because it's not a trinomial. So it's also got subtraction. So automatically in our mind we should be thinking difference of squares. So does this follow the difference of squares rules? So remember, difference of squares has subtraction in between 2 perfect squares. Is y squared a perfect square? Yes. Is 25 a perfect square? Yes. So our factors are going to be the square roots of the 2 terms. So the square root of the first term is y. The square root of 25 is 5. One will be minus and one will be plus. So again, you can certainly use the app, but hopefully we'll get to a point where you don't even have to use the app to do difference of squares questions. All right, number 4. So this is also going to be a binomial over a binomial. So 2x squared plus 16x over x plus 8. Okay, so in the previous example, we had subtraction between 2 perfect squares. This is also a binomial. Could it be difference of squares? Could we use difference of squares to factor this? Well, we're not talking about subtraction. It's 2 terms being added together, so we definitely can't use that. Let's see if we can do this in our app. You can actually put this in your app in the calculator, but it's really not going to give us all of the information. If we have a binomial like this that cannot be factored by difference of squares, we probably need to look for something else first. If you notice what we get our solutions of 0 and minus 8. Okay, so to me, that looks like the factors x plus 0 or x minus 0 and x plus 8. Okay, well that's kind of nice because we've got an x plus 8 there. We might cancel. X plus 0 would just reduce to x, but there's actually something that we're going to miss if we just go straight to the app on this one. We always, always, always have to look for a GCF. Okay, you always have to look for a GCF first. So it's something that we didn't really need in the previous examples because they all were leading coefficients of 1 and they were just quadratic expressions. They didn't have like all of them sharing a variable or anything like that, and they only had a leading coefficient of 1. So in this case, we do have a GCF. We can actually factor something out of 2x squared plus 16x. So what is common to both 2x squared and 16x? Well, we could say the number 2, and they both have a variable x. So if we factor out 2x from both of these parts, meaning we divide both part by 2x, divided by 2x, that becomes a factor. So 2x becomes a factor, the GCF, and then whatever's left becomes the other factor. So let's see what we get. 2x squared divided by 2x is going to give us x. 16x divided by 2x leaves us with a positive 8. So we do in fact end up with a factor of x plus 8, but if we don't consider the GCF and we just plug numbers into our app and our calculator, it's really not going to tell us the whole story. So we factored the top part. Our next step is to cancel the common factors. We can cancel x plus 8. So our final answer is simply 2x. Okay, so moral of the story, always, always, always look for a GCF. Always. Here's one. Let's see if we can take a GCF out of this next one. So in this one, I've got number 5. I've got 2x squared plus 5x minus 12. Okay, so this has a leading coefficient greater than 1. That means the first coefficient is larger than 1. So this is a hint that it might have a GCF, not necessarily, but it might. So let's see if there's a number or a variable that we can divide every single one of these terms by. Is there a common factor for these terms? No, there's not. But we can put this in our app. So there's the numerator, here's the denominator, 2x minus 3. So here's how we do this with the app. We're going to factor the top, just like we've been doing. Okay, so we go to our app, turn my calculator on. I'm going to clear my coefficients. In this case, I have a coefficient of 2 with x squared plus 5x minus 12. So let's make sure that's all set up correctly. Okay, let's solve. So it's important that your calculator app is set in fraction mode so that we can change this around. All right, so this is what we get. We get x minus 3/2 x plus 4 over 2x minus 3. All right, so right here, if I see a fraction, this right here is a red flag. I cannot leave a fraction in the factor. So do you remember what we do to change this? Think back. It all comes from the numerator and the denominator. So here's what we're going to do. We take the denominator and move it in front of the first term. So now we have 2x minus, and we leave the numerator, 2x minus 3. So again, we took the denominator 2, put it in front of the first term, so 2x, and we leave the numerator 3, 2x minus 3. Our x plus 4 doesn't have a fraction, so that stays the same. And we've got 2x minus 3 on the bottom. This should look pretty nice. Cancel those out. Our final answer is x plus 4. Last question, I've got a binomial divided by a binomial. Look for the GCF. What can we divide out of both terms 10x minus 15? We can take out a 5, and that's about it. So divide both terms by 5. We're left with 2x minus 3 over 2x minus 3. Cancel. Our answer is just 5. All right, make sure you ask me any questions that you still have, and good luck on the practice.